Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Triangulation is brought to you by Cashfly at CACHEFLY.com.
This is Triangulation, episode 154, recorded June 9th, 2014. Mark Miodownik. Triangulation is brought to you by NatureBox, where you can order great-tasting, healthy snacks delivered right to your door. Forget the vending machine and get in shape with healthy, delicious treats like whole wheat lemon figgy bars. Oh, baby! To get 50% off your first box, go to naturebox.com/twit. That's naturebox.com/twit. Welcome to Triangulation. This is the show where I look forward to this every week because we get such interesting, unusual, unique people in here. Some of the biggest minds, the smartest brains, the greatest talkers on the internet, and we get to talk to them for a whole hour, and you're going to love this next hour. Our guest is Mark Miodownik. He is the author of a book called Stuff Matters: The Strange Stories of the Marvelous Materials That Shape Our Man-Made World, the Science Book of the Year in 2013, according to many. Just an amazing book, and I'm so thrilled to have him from London on Skype with us. Mark, welcome to Triangulation.
Great to be here. Yeah, thank you.
Thank you so much. I want to ask you about those gauges on the wall over your left shoulder there. Is that just a clock, or it feels like scientific meters of some kind?
Well, it is actually. One is a rain gauge. So these are maritime pieces. So one's a clock and the other one's a rain gauge. Yeah, so
they're
pressure
beautiful,
sensors, essentially, and a timepiece.
They are beautiful works of art. Those marine chronometers, and of course, in the early days of navigation, very, very important pre-GPS.
Well, you couldn't navigate. You didn't know where you were unless you had an accurate clock, and that was a result of the longitude prize,
right?
Which was because they couldn't tell where you were. You couldn't tell where you were longitude-wise in the world until people had accurate clocks. It's a weird thing, but you need to have accuracy down to a few seconds over thousands of miles of travel. Otherwise, it was in those days impossible to find out where you were longitude-wise.
Everybody who lives in Britain probably knows Mark from his appearances on BBC Radio, on TV. He's, according to the Times, one of the top 100 most influential people in the United Kingdom. Science, Royal Academy of Engineering Rook Medal winner last year. In 2014, UCL Media Communicator of the Year. He's written, we mentioned the book, but he's written papers I'm looking at your scientific papers, the broadest range of science ever. What is your actual scientific background, Mark? What did you study?
I studied material science at Oxford University. And what is that? I mean, what is that, you might be asking? Well, it's the physics of atoms. It's the quantum mechanics that determines how they bond together. It's the chemistry of molecules, but it's also the crystal structures of metals, the crystal structures of things like concrete and cement. And it's also the strength, the toughness, why some things are colored, some things are transparent. And it's how you make these things. So it's the processing. How do you make steel? How do you make paper? And so it's the science that governs how the world is made. Everything is made of something, and to understand how that's made, you need to not only know the physics and the chemistry and the biology, but you have to know the engineering, but also that there are design constraints that you have to take into account. So it's all of that together, which is quite a broad degree. And I that's the kind of person I am, as you were just saying by looking at my scientific output. I have an eclectic mind, and I'm curious about the world, and I find it very hard to resist when someone comes along with a research proposal and says, do you know what, could you help us understand why some metals taste different from others? And my response to that wasn't, well, that's not my research area. It was, you know what, yes, I would love to find out about that.
Well, look, you have an article on tasting spoons, assessing how the material of a spoon affects the taste of the food. From that to a biomechanical analysis of the ventral furrow formation in the Drosophila melanogaster embryo. I mean, that's biology, that's metals, wow, I love it.
But that's what I was telling you, is that actually once you study how atoms bonded together into molecules, and how molecules become macromolecules, and how those can be assembled into membranes. You have a cell, and you can start. That's a material. In fact, the cell is the dream building block. You can take a cell and you can make bone. You can take a cell and you can make hair. You can take a cell and you can make us. Every one of us started from a single cell. And so if you want to look for the epitome of the most extraordinary made objects, it's us, right? We are material, animate matter. So of course, if you're interested in materials, you have to study the living world. But at the same time, life hasn't managed to get to the moon. We did that. We did that with human technology, and that's mastering high temperature metals and rocket fuel, and so the subject's very broad and wide, and that's what's so enjoyable about it for me, is that I get to it's a bit like being an adventurer in the old days, right? But instead of exploring the forest of Africa or the Antarctic continent, I get to explore these tiny microscopic worlds, but they are almost infinite in their extent.
They're limitless, yes.
Yeah.
It strikes me that great scientists, great thinkers, are paying attention more than we normal folk are. And we were talking earlier about celebrating. You've written an article on celebrating your washing machine, and that's a perfect example of something we just normally just completely take for granted. A clothes washing machine? What are you talking about? That's just an appliance. And you're paying attention. You're saying, no, wait a minute. That's your robotic slave.
Yeah, I mean, the washing machine we have now, I bought 7 years ago. We had a party for it when it arrived, and because it saves me so much time,
right.
And also because of it, I get to be taken seriously in public because I'm not naked. But not just that, my clothes are not dirty and stained.
Yes.
And it sounds ridiculous, but of course, if you did go around with dirty and stained clothes all the time, people do, in a sense, don't want you around them. That's what culture is. And so the washing machine is this kind of really important thing. It's a bit like my nanny, in a way, if I had a nanny. It's kind of taking care of a very important aspect of my life. And it deserves, you wouldn't ignore your nanny, right? They do something for you every day, every week. So why do we think machines are different? And it's not that I think the machines have a personality that are alive in any way, but but they are part of who we are. They're an expression of our culture and of how we live. And they're also an expression of equality, because before the washing machine comes along, essentially most clothes are washed by women. And, and as soon as you have the washing machine, it really frees up both sexes.
Women who spent hours down at the river pounding the clothes, they didn't even have washing soap. I don't know what they used. They would pound them with rocks. Yeah. That's not so far in our distant past.
No, it's not. And it's really extraordinary. And so the washing machine, I think, really embodies, if you want to pick a few items in your house that embody what modernity is and how engineering has created a life which you really wouldn't want to go back to those days.
Yeah.
However much people are nostalgic about the past, and you might want to go on holiday and stay on a ranch and ride a horse, but you don't want to do that every day.
You definitely want a flush toilet, and you definitely want a washing machine. There are certain things we've just become used to. We live like kings. Every once in a while, I think we live like the most wealthy royalty of 300 years ago. The most simple person lives better than.
Yeah, and I think that here's the thing why I feel it's worth writing articles about washing machines and celebrating this, because we have no trouble celebrating an author or celebrating a filmmaker, and I'm totally with you on that. I mean, I think that's an important part of human culture. But making machines is just as equally important and actually culturally relevant.
It's probably more important.
And they don't get their day in the sun. There's no Oscars, right?
Yeah.
For the washing machine. And there should be, for the best wash of the year. You know what I mean? Like the most satisfying, the most important wash of the year.
I love my washing machine. In fact, in the biography of Steve Jobs that Walter Isaacson wrote, there's a very telling paragraph in which Jobs took a week with the family researching washing machines, because there was the choice of a faster washing machine that wasn't as gentle with the clothes. They chose a very gentle, slow washing machine. The clothes came out soft. I mean, he paid a lot. This is Jobs. It tells you a lot about Jobs. He paid a lot of attention to even those little things.
Yeah, and I think and also, how do you make a washing machine? If you really look at it, it's a marvelous piece of technology. It has a stainless steel drum that never seems to get tired and tarnished. It's always, you look inside it and it's always pristine and clean. And that's a wonderful thing to do because, you can entrust your special clothes to this
you
thing
wouldn't want it
that
to be
never
dirty.
seems to get dirty. Yeah. And it's magic too, right? In go dirty clothes, out come clean clothes. And, I mean, I do think that as soon as you kind of open yourself up to the marvelousness of what we've created, it's every bit. I mean, I think the urban world that we've created is every bit as marvelous as a tropical jungle.
Oh, yeah.
And people go to great extent, and rightly so, to kind of praise how diverse and complex a tropical jungle is. But I think a modern city, has that beauty too. It's just that people are used to sort of somehow ignoring it all.
Where you're sitting and where I'm sitting, virtually everything we can see was engineered by somebody. Somebody spent a long time designing it, thinking about it, creating a manufacturing process, making it. There's very little the natural world has created around us. This is all engineered.
Yeah.
It's amazing
And
if you start to think about it.
And everything is made of something. And those things that they're made of are materials. And that's where we are. I mean, that's how it all, that's why materials are interesting, because they afford, the affordance of materials gives you this stuff. And you couldn't have predicted really that, let's say, it would have been possible to make something that's as simple apparently as glass is a miraculous material. And it has changed so much about the way we live. But not just that, it's changed the nature of ideas. The history of ideas is deeply influenced by glass. The history of science is deeply influenced by it. And even religion. And that's just one material. And then if you look around you, the richness of all the different materials around, there's plastic and metal and concrete and leather and wood. And, you realize that each one of those materials was a revolution in its time and still has this enormous effect on us, which is why, of course, the ages of civilization are named after materials. So there's the Stone Age. And if you don't get out of the Stone Age, if you can't work out how to turn stones into metal and make tools, then you stay in the Stone Age, Yeah. And then you get to the Copper Age, and then the Bronze Age, and the Iron Age. And each of those ages takes us to a different facet of human consciousness, because I think as we've become more advanced, it's allowed us more time. It's allowed us time to think and time to develop our ideas. And it's only materials that have allowed that. So we're constantly evolving what it is to be human. And that's about technology as much as it is about anything else.
If you don't have these time savers, you don't have leisure. If you don't have leisure, you don't have creativity. You don't have art. You don't have those movies you talked about. You don't have any of that because it takes leisure time to create. We need surplus in order to create. And in years gone by, the only people who had surplus were the pharaohs, were the kings, were the people who had many serfs taking care of them. Now we have little robotic serfs. We're talking to Mark Miodownik. His book, Stuff Matters, Exploring the Marvelous Materials That Shape Our Man-Made World, just came out about a week ago. It's available in Kindle as well as hardcover. Maybe you're caught in the Amazon wars. It says usually ships within 1 to 4 weeks, but I think you could probably get it faster if you did a good thing and went to your local bookstore and said, I would like Mark's book. This is so cool. This is so exciting. Why is glass clear, Mark? So it's a special material. You'd think that's a simple question, isn't it? But in fact, if you think about it, why is it clear?
It's a very deep question. And I think it not wanting to kind of turn it around the other way, but the real question is, in a sense, why isn't everything transparent?
Why is stuff opaque? Yeah.
Yeah, because if you look at an atom is mostly space.
Right.
If an atom was the size of a football stadium, then the nucleus would be a pea in the middle.
Wow.
And the electrons, which are the rest of the atom, would be these tiny specks of dust in the numbering anything up to about 100 in the stadium. The rest of it's space. The rest of it's empty.
So not only why can't we see through it? Why can't we just put our fist through it? Why does material even exist? It's all space.
It's all space, and you would have thought that light could easily travel through that without hitting anything.
Right.
So then it turns out that view of the atom is missing something. It's missing the fact that it's a quantum entity, that there are electromagnetic fields inside it, and that a light is an electromagnetic field itself. And so those two interact. So it's not just about traveling across an extent of space. It's whether those two interact and strongly or weakly. And in the case of glass, the electrons I was telling you about, they can absorb that light if there is a space in the stadium for the energy given to an electron to move to a new seat, let's say. And so if you think about the seats of a stadium higher and higher being sort of, more higher energy, then if a piece of light comes through, a photon of light comes through, and it can promote one of the electrons to a higher state, then it will be absorbed. And that's what most of matter does. That's what most of matter is, opaque, because actually the light comes through, it hits a few atoms, it absorbs the light, and then it's given out again as heat later on. So that all the atoms inside glass, almost all the atoms inside glass, have electrons in seats in the auditorium, in the stadium, which are unable to move to a higher seat. They're either full up, or the light, the amount of energy you would need given by the photons, not enough. And so the light has no choice but, as you said before, to travel straight through it. And so it's the quantum. It's one of those things where it's the quantum mechanics inside the atomic bonds inside matter that make something transparent or not. And that's it, really. That's it. So if you want to make something colored, of course, colored light, like a red light or a green glass or a red glass, you can let most of the light through and just have the photons with that are either blue or yellow absorbed, and that will absorb those photons, but not the green ones.
And
they
you
will
do
pass
that
through, and you see that
by doping the silicon with impurities that absorb light.
Yes, and they form local bonds which have an electron in a state which can be promoted to a higher state. It's available, and so therefore it does.
Oh, that's interesting.
So when you're inside a metal or inside a glass or inside a piece of concrete or inside a plastic, there are electrons. They can do things. When they vibrate, they're giving, they provide heat energy, and when they move up and down these states, they can either absorb light or give light out. And so when you see something that's fluorescent, so fluorescent jackets that look very yellow or sort of almost greeny yellow, they absorb very high energy light called UV light, which would normally give you a tan. They absorb it because they have particular energy states that are available to it. But then the electron falls back down to a lower state, and that gives out a photon of yellow light. So it absorbs invisible light and gives out yellow light. And that's why they seem to glow, because actually they are giving out light that they didn't absorb.
Wow.
And when you have that in your bedroom, like my son's bedroom has stuff that glows in the dark.
Right.
What it's doing is it's a fluorescent material, exactly like I just described, but there's a time gap between the photon of light coming in, the UV light being absorbed into these energy states, and it being and the electron falling back down and giving out the yellow light. And that if that time delay is a matter of 10 minutes or 20 minutes, then when you turn all the lights off, there's 10 or 20 minutes worth of these things being released. And that's why it glows. I
always wondered that. So you shine the light on the fluorescent material for a while, turn out the lights, and then for another 10 minutes, it's going to release those photons that it collected.
So it's basically stored light inside the electron state, and then gives it out again. And there's some people in America, and I've forgotten which university it is, who've been trying to increase that delay, because you can imagine if you could make that delay time 12 hours, then you could have almost all indications on the roads.
Is that Laszlo?
Yeah. Hi, Laszlo.
Hi, Laszlo. This is the luckiest kid in the world. Can you imagine having Mark as a dad with the amazing stuff that this kid is going to get exposed to? Does he now? How old? He's about what, 2?
He's 3. 3 today, yeah. Yesterday.
Do you do stuff with him along these lines? I mean, are you trying to open his eyes to the miracles that are around him at all times?
The funny thing about being 3 is everything is a miracle.
You kind of know.
Like,
yeah.
It is. They have the eyes that you have to regain after.
Right.
After you get through your teenage years, where everything closes down, and you get into sort of you find the world depressing and annoying and in any way unacceptable. You have to regain your childlike state in order to be a scientist, I feel, and it's that scientist curiosity about the world that is what a hallmark. And for me, luckily, I had 3 older brothers who'd been through teenage and been really appalling. And I, for some reason, skipped that kind of moment. So I, a bit like Peter Pan, and kind of forever 3 years old in a way. I never seemed to kind of get bored of the world.
You kept your sense of wonder. I love that. I love that.
I sort of, I got lucky on that front.
Mark also does have, I realize our geek audience, and this is a geek network, so you're talking to geeks who kind of probably have also kept their sense of wonder, one hopes. But they know you from the science of Doctor Who, because we're all Doctor Who fans here.
Oh, yes.
Yeah. Is it possible is it possible to create a TARDIS that has more space inside than it appears to on the outside? I don't think so.
Well, I mean, it's weird how our understanding of scale and space is what we would consider to be to do with common sense, wouldn't we? Because we learn that things inside and out are roughly the same, and they're all Euclidean space.
That's the process going on right now in Laszlo's brain. He has no predictive model for the world at all when they're born, right? And they are just learning. All that's happening, as I understand it in the brain from our previous guest, Jeff Hawkins, is a predictive model of, okay, so it looks like that. It must be that big. It's that far away, and it's all about that, yeah?
But there's some really interesting materials now that are going to change our notion of space quite a lot. And these things are called metamaterials. And what they do is so we talked about transparent materials. Yeah. And one of the things you notice with transparent materials is that they bend light because they have what's called a refractive index. And that's different from air. So when light hits it and goes between one transparent material, air and glass, the light bends because they have different refractive indices. And so that's why swimming pools look a bit, shallower than they are and all these sorts of things. If you can bend light inside a material, then sorry, I should have turned this off.
Oh, that's all right.
If you can bend light inside a material, then you can bend it round things. And these metamaterials, what they are, they're materials that are controlled at a microscale, so they can bend light in any direction. And that means you can take a metamaterial as a kind of cover, put it over something, and as light hits it, let's say I had it over my head, as light came in this side from here, it would bend it round my head and then shoot it out the other side as if it gone straight through my head.
I like it. I'll buy one.
Yeah. And so if you were looking at me from over here, you wouldn't see my head. You would think I was invisible because all the light's approaching this side, going out that side.
Right.
And if you can do that unidirectionally, which people now can, you've essentially invented an invisibility shield. And so these things now exist, and they really just are trickling light to go around objects. And at the moment, it doesn't work very well for visible light. So you're not going to see an enormous number of visible applications in that sense. But people are doing some interesting things, and it may yet happen. I mean, it's theoretically possible. But people are doing interesting things about bending heat, because heat is a form of light. And why would you want to bend heat? Well, actually, your processor in your phone and your laptop heats up, and that's one of the limiting factors of its speed. So if you could bend heat around the crucial parts, then you could keep it cool. And we were just talking about TARDISes, but if you can bend light, you can make something that is a very large space appear to be quite small. So although I'm not saying that you're going to see a TARDIS any soon, and in fact, but this trickery of the light, that's all happening now. People are really getting into using materials to manipulate light, and it's an enormous area of research.
Fascinating area. I mean, because almost everything really is electromagnetic radiation of some form.
Yes.
So you could, for antennas, for lenses, you invented the invisibility cloak. I think that's pretty cool. Sound. This would be amazing.
Well, sound is slightly different.
Sound is air pressure, not
air
electromagnetic.
Pressure, yeah.
But they are using it for sound. It looks like.
Yeah, so it's some same principles, and So I mean, obviously, if you 100 years ago, the biggest shows in London, at the big theatres in London, and there are about 100 theatres in London, but the biggest shows were magician shows. And when you go and look at the history of those shows, what they really were bits of engineering and science that hadn't hit the high street yet. It was emerging science. And instead of having a science TV program and displaying it like yours is today, the magicians got hold of this stuff, and the people had never seen it before, and they presented it as magic. And now we're not so used to it, but if you really think about what you can do with a mobile phone and what that,
it's pretty magical.
And whether you could, it is pretty magical, isn't it?
Magical.
And these metamaterials, these invisibility cloaks, and they're all going that way to a clear sense of it's hard to work out how things work. And I think it's a bit of a dilemma, isn't it, for science and engineering, whether to kind of go with the glory of producing amazing technology that no one understands, or trying to unpick it and let people have an insight into how it works. And I suppose I feel like the former is important, even though a great magician show is a wonderful thing to see, because ultimately I think technology defines culture more than anything else. And people don't have much understanding of it, then it will be devalued, and that will be a big shame, because it's central to everything, and yet doesn't quite get the credibility it should.
Well, worse than that, if we don't have people understand it, we can't get anything new.
Right, that's true. Yeah,
There's also that, right? I mean, we don't want to have a priesthood, the only people who understand how things work, although I guess that's how it kind of has been for millennia.
Yes, it is.
But if you went back in time to those magic shows of London 150 years ago with your cell phone, you'd be a magician. You'd be pretty hot.
Well, the first demonstrations of television were displayed as magic.
Interesting.
On the stage, and people, here's an image of a person. I mean, that was just unbelievable, to people.
Yeah.
So there is this magical element, this performance element to all of these technologies, and I guess you mentioned Steve Jobs before. I think he picked up on that. He had this feeling for theatre in the way that he presented his products and the way he announced them, and I think that has cottoned on, and I think that's a great thing. It's given technology a stage that you really should have.
Yeah. We're talking to Mark Miodownik. He is a professor. You must have invented this title, a professor of materials and society.
I did.
I mean, that is a perfect title. At the University College of London, and also a very successful and well-known broadcaster in the UK and author. And his book is out now in the United States. You can get it for yourself. It's called Material Matters, Stuff Matters, exploring the marvelous stuff that shapes our man-made world. His webpage, markmiodovnik.net, has a lot of great stuff on here. And I want to find out how the metal of spoons affects the taste in just a second. But we're going to do something here. It's snack time in the United States. In fact, if you want to put Laszlo to bed or something, I'll give you a couple of minutes while I talk about NatureBox, and you can go ahead.
Okay, fine.
You can go ahead.
I'll go and
go
hear a few yelps.
Yeah, Laszlo, go to bed. It's time for bed. Although he'd probably enjoy a little of this coffee kettle corn with coffee caramelized, popcorn. Holy cow! Or maybe we could give him don't give him any peppery pistachios. That's a grown-up taste. Maybe South Pacific plantains. They have great dried fruit. We're talking about NatureBox. NatureBox is great snacks delivered to your door every month, 3 sizes of boxes, so you can decide how many snacks you want. We get them here at the studio, and the staff just loves them. It comes time of day you want to get a little something out of the candy bar machine. Don't do that. Get a NatureBox snack instead. I've got to try these plantains. They have the best dried pineapples ever. In fact, Lisa loves the dried pineapples so much. We ordered an entire box just of NatureBox dried pineapples. If you go to naturebox.com/twit, you can see, these are like potato chips. Oh my gosh, they're good. Made out of plantains. Every one of them designed by a nutritionist approved. Not one NatureBox snack and there are hundreds. She's eating the pineapple right now. Have high fructose corn syrup. There are no partially hydrogenated oils, no artificial sweeteners, flavors, or colors. There is no trans fat. You can choose, if you wish, you can get a complete assorted box, or you can choose sweet, savory, or spicy. You can choose to fit dietary needs, gluten-free, gluten-conscious, that kind of thing. Vegan, of course. They have, look at all the flavors. I would guess, my suggestion is go out and get a variety for your first box. And by the way, we'll get you half off that first box. So get the complete variety pack so you can get a sample. How about this? I've never seen this one. An antioxidant boost. Yeah, this makes you feel good about eating trail mix with dark chocolate and berries. Oh my gosh. I'm only allowed to open one bag during each commercial. So I've committed to the plantain chips, but I'm going to try that next time. naturebox.com/twit. 50% off. Actually, Karsten, why don't you open this? Because I really want to try it. This is good. I'm going to cheat the NatureBox ad. Open the antioxidant boost, then I can have some. naturebox.com/twit for half off your first box.
There you go.
See, it wasn't me. Karsten opened it. Trail mix, antioxidant trail mix with dark chocolate and berries. Oh, it's rude of me. I apologize. We found a loophole in the rule. The reason I can only open one bag is because in the past ads, I've opened every bag. And that kind of spoils the nature box for the next guy. These are all, by the way, it really doesn't, because they're all resealable bags, Ziploc bags. And the cost before the discount is about $1 a bag. And you can get it down to less than that. And they are well worth it. naturebox.com/twit. We're going to take a little break. Mark is putting Laszlo to bed. He's disappeared. I'm reading your article about milk carton tops, milk bottle tops.
Oh, yeah.
I don't know if this is true in the States. I like you, am not observant enough to have noticed this. But they're going green, not because it's somehow a more psychologically better color, or it makes the milk taste better, but it's because the green pigment of semi-skimmed milk bottle tops affects the ability of the plastic to be recycled.
I can't remember when I was last in the States. I can't remember whether you had milk in.
We do have plastic cartons, yeah.
High density polyethylene.
Yeah, I'm pretty sure we do.
These are fully recyclable materials, and in fact, the move away from glass has been very beneficial for the environment because
that surprises me. You think of glass as being completely reusable, or at least recyclable.
It is very recyclable.
Yeah.
It's not that. It's that when you cart milk around in a glass container, because glass is brittle and dense, you have to create. You have to have a thick bottle, and you have to have a lot of it.
Right. It's
and
heavy.
That's a huge amount of weight.
Yeah.
And that costs you energy.
Right.
And so that's energy. And if you compare the energy density to the plastic, it's about a tenth. So now you have a material that's costing you much less in terms of energy moving around. And that turns out to be one of the biggest influences here. But the problem is that people don't tend to recycle the plastic bottles as well.
We don't think it is recyclable, I think, in a lot of cases.
No, that's a problem. But even when it is, and it is an amazing process, recycling of these plastic bottles, if there's colored plastic in there, then although it's made of high-density polyethylene, it will make the bottle not fully white. It'll make it slightly green or blue or red, depending on the bottle top color. And so the real solution to this is, and that makes it less valuable. And because it's less valuable, then people will recycle it less and so on. It's a vicious circle. So the real key to this is to try and persuade the supermarkets to put up with colorless tops. If they were the same color as the bottle, the whole thing would be fully recyclable and be really easy. But they won't do it. Why won't they do it? Because they say that the shoppers prefer to be able to see it at a glance.
That's that's how we tell what grade of milk we're buying.
Exactly.
Skim, 1%. Yeah.
But it's not beyond the wit to put that information in some other design way, right? That is like a paper label.
Figure that out. Yes.
You know what I mean? And this is
as you point out, they've done it in Japan since 1995. They passed a law.
in Japan, they realized because they haven't got a large amount of mineral, they aren't
The natural
well
resources
endowed
are
with
scant.
natural resources.
Yeah.
They decided that actually to be a competitive country, it wasn't just for environmental reasons. Like they really needed to be recycling all of their stuff, and they just put it in law. They just said, if you're a manufacturer of this stuff, you have to recycle it. You have to make it easy to recycle. And they're up to 75, 80% recycling of this plastic.
Wow.
So it's definitely possible. And, I do think it's one of the things that we really need to sort out in the 21st century. We're so sophisticated in many ways in our technology, phones and cars and planes and rockets and satellites. And yet we still dump our waste in a hole in the ground. I mean, it's a bit like, pissing in your back garden. It's just, no one, it just does it's not even whether it's environmentally good or bad or economically good or bad in my view. It's about our pride in ourselves. If we're going to call ourselves a technologically savvy race defined by technology, then I think we just can't be throwing amazing materials like plastics in a hole in the ground. We just can't be doing it.
That may be the best argument for scientific literacy, not so much so that people know why glass is transparent, but so they can make rational political decisions, societal decisions, well-informed, and even just start thinking about this stuff. I think we're, as I said at the beginning, kind of unconscious in general about the world around us, and it's not so complicated. Although your obsession with fruit fly furrows does seem a little, maybe perhaps a little. What is it with the ventral furrow of the fruit fly?
The ventral furrow, man. It's fascinating. Some people are fascinated with the craters on the moon. I get my kicks in the ventral furrow of the Drosophila fly.
Why?
So as I said to you before, I mean, the cell is the most extraordinary building block. So however good we are at making skyscrapers and roads and bridges, my God, the San Francisco,
the Golden Gate Bridge, amazing, isn't it?
Bridge.
Architectural
it's an amazing
thing, yeah.
But it's not as amazing as the ventral furrow of the fly. And the reason it's not as amazing as the ventral furrow of the fly is because the ventral furrow of the fly makes itself. It doesn't need cranes. It didn't need designers. It didn't need architects. It makes itself, and it is unbelievably well engineered.
Yeah.
It's a piece of mechanics, and I and many other people in the world have got obsessed with the fact that if you consider how living materials assemble themselves and create things like trees or whales or us or a blade of grass or a bee that flies, they all start out from a single cell.
Right.
So they start out from one cell, and that cell divides, and that cell divides, and they all divide, and they get bigger and bigger and bigger. But you don't just get a blob of cells. They start to form structures.
They differentiate.
But no one tells which cell to go where, right? It's kind of, they all sort of know somehow. They do signal each other, and different chemical signals are given out and different mechanical signals given out. And you get this intricate structure, tunnels and bridges and of course in the end wings and legs and eyes that can see, and all by just cells dividing, changing shape a little bit, and then dividing again. And so what we thought is, if you can study that, if you can study how something so simple can create something so complex as a fly, you will know more about how to make complex things of the future. Okay, we might say, well, we can make a mobile phone and you can make a fly, so fine.
Yeah, but wouldn't it be cool if you go to the store and buy a little bottle cap that you throw on the ground and go boom, and then it's a garden shed?
Exactly. That's exactly where we're going.
That would.
So the idea.
But we could do that, you think?
No, well, but nature does it, so it's clearly possible.
It's possible.
So we will do it. I mean, I don't think there's any reason we won't do it. We will do it. We will make bridges that build themselves. We will make bridges that heal themselves. I'm absolutely convinced that's the direction we're going in.
They would have to be biological in some way, though. They'd have to be alive, right? Okay, well, that's a very interesting point. So the question is, what do we mean by alive? If alive means that they will have senses and they will know, they will know which bits of the bridge are building, then yes, I think that is what they will be. And if alive means that they can heal themselves, then yes, I think they will be that too. I think it's quite a hard thing to define what
the difference between animate and inanimate matter is. Because if you go down to the nanoscale, the scale of the inside of a cell, and look at all its processes in which it's essentially chemistry. I mean, at the moment, I guess it's true to say that we don't know everything there is to know about a cell. I mean, that's for sure. But no one has ever managed to find anything in a cell that isn't a piece of chemistry that they basically understand.
Right.
So
it's really remarkable. I mean, the building blocks are just fundamental chemistry and physics, and yet it creates something that is at the end point sentient. But all we are, these sentient creatures, is just a bunch of cells that are, I think you could say, not sentient.
That's the conundrum. That's the conundrum. And I think the biggest, although in Europe anyway, all the big fuss goes around the Higgs boson and the Large Hadron Collider as the kind of epitome of science. But in some senses, I think it's almost the wrong question to ask. Not how small a particle is the universe made of, but really, what is life? What is life? I think that is probably going to be the biggest question of the 21st century, and it also will feed into something else, which I think from a technological point of view is one of the most important applications, which is that as we all get older, we probably don't want to live forever. We probably don't want to live to a 500 or 1,000. I think it would be quite hard to cope with. Maybe there'll be people in the future who do that, but now that would be a big step change. But what you definitely could cope with, and I think I speak for everyone, is that you want to get to the age of 100 and still be able to walk.
Yeah.
Is that too much to ask?
No.
And still be able to go for a run.
Quality
and go
of
for a
life.
swim,
I don't mind if they cut it off at 100, but if it's I'm 100 like this for the next, that would be great.
Yeah. And that is all about understanding this question of the ventral furrow. I mean, not actually the ventral furrow, but the questions that are like that, right? Which is not only how do bodies build themselves,
but why do
how
we age?
degrade?
Why do we degrade? Yeah.
Yes. And also how we can implant things into the body that will allow you repair your faculties and keep you going, keep you on the road, as it were, until you're 100, independent in your own house. And that rebuilding the human body and understanding the human body is a material science problem. It's not just a biology problem. And anyone who's ever had a hip implant will tell you this.
Right.
Anyone who's ever had a cruciate ligament replacement will tell you this.
Right.
And biomaterials are going to be an enormous revolution if we can get them right. And
it does verge into the realm of religion a little bit.
Yeah, well, I think.
I mean, that's the only human discipline that has an answer to what is life. It may not be. I mean, it may be a superstitious answer, but it's an answer. Science has yet to answer that.
Science has yet to answer it. Yep, science doesn't have a good answer to what is life. But I think that is going to be the biggest Nobel Prize to be won in the 21st century. I'm convinced it will answer that question, and it's not even clear whose ball court that's going to be in. Will it be a physicist? Will it be a chemist? Will it be a biologist? But my bet is it'll be a material scientist, because it'll be someone who makes a bridge that is a kind of alive, and people always go, okay,
now
that's
what?
alive then.
Does this bridge have human rights?
Yeah. Well, I definitely think we're going down that road. Robot rights or bridge rights.
But of course, that's exactly what we want: self-healing, self-building bridges, and garden sheds, and automobiles, and everything else.
There is already self-healing concrete, and this already exists as a product, and it's a very interesting way of approaching the problem, because what it consists of is concrete, which has got bacteria embedded in it, and it's bacteria that can withstand extreme conditions. They were found in kind of hot springs, and they will lie dormant inside the concrete for 50 years. But if there's a crack and they get exposed to warm air or humid air, they wake up and they look around for food. And the concrete of this kind has starch embedded in it. So they find the starch, they eat the starch, and then they poo. And they poo out calcite, which is a mineral, and it's one of the major constituents of concrete.
Oh, my
and they eat
God.
them, and then they proliferate, and they eat their cells out of the crack, leaving behind them pristine concrete.
Oh, my God.
Yeah. And then they get to the surface, and then they run out of food, and they unfortunately die for them, unfortunately, but leaving behind a piece of concrete that's been healed. So it's a sort of composite material of what you would call an inert material with a bacterial element. And I think you'll see a lot more of those types of materials actually in the future as well.
So this work is being done. People are researching.
Oh, it already exists. It already works. In fact, the tests show that you recover 90% of the strength of the concrete.
Wow.
If it's cracked.
So there is a journal called Food Quality and Preference.
Oh, yes.
And you were co-author of a study on tasting spoons, assessing how the material of a spoon affects the taste of the food.
Yes.
That makes sense, because you've had metallic. I mean, sometimes spoons, you could have a spoon taste metallic. Oh, wait a minute. He's opening his briefcase. What do you got in there?
Well, if you want to talk spoons, I've got to give you the spoons. I don't go anywhere without my spoons.
Oh, my God. Well, there are different, like copper and stainless steel and
yes,
different flavors. What flavor is
silver.
that? That's silver. Okay.
I went to a dinner. I had lunch today at a kind of the Royal Academy of Art, and they have silver cutlery.
Yeah.
And I said to them, silver's not the best material for cutlery. It still tastes. What you want is this material, a revolutionary material, a new 20th century material. It's called stainless steel. Everyone else has it. How come you guys haven't?
Wait a minute. Cheap stainless steel tableware is better than silver because the silver tastes like metal.
Well, still, yeah. When we did the tests of these different materials, so we did blind taste tests on these different. That's copper. This is gold.
Copper. Now, gold supposedly has no taste. Gold
is very inert.
Yeah.
And stainless steel and gold are very similar in that sense.
Yeah.
But one is much cheaper than the other. This is tin. This is very tasty material. This is zinc, which is extremely bitter and metallic.
Never make your tableware out of zinc.
Don't use zinc. So this is the thing, right? So stainless steel is a revolutionary material until the 20th century, early 20th century, when a guy called Harry Brearsley in Sheffield accidentally discovered it. Everyone who wasn't rich and couldn't afford silver or gold
had tin, probably.
Stuff. They had tin, they had pewter, they had iron, they had wood.
Pewter's got lead in it. That's probably not a good choice.
I know, but they had them.
That's what they had.
And so all of our ancestors, okay, I'm assuming that most of us weren't from rich, families.
Right.
They all tasted their spoon as much as they tasted the food. Like, so
Does it add that much flavor? Is it no? Is it?
Yeah.
Yeah.
Massive.
We're just used to it. We take it for granted.
Have you ever gone to a takeaway? I mean, what is it called?
Yeah, takeaway. Go to go place. Yeah.
And you've ordered, let's say, a chili or a soup.
Yeah.
And they've given you a wooden spoon to eat this with.
Yeah.
Do they ever do that? They do that here a lot.
Yeah.
Because they think wooden is somehow environmentally sound.
Tastes
but it's
like
not.
wood.
Yeah. It tastes exactly like wood. And pewter's strong tasting, and so's copper, and so's bronze and brass.
What about plastic? What about plastic cutlery?
Actually, plastic is a really good choice for a takeaway, as long as you can recycle the material. And often that is difficult because it's such a small thing.
Right.
It tends to get thrown away.
Right.
And did you know? Of course, I mean this is a digression, but the birth of cutlery, the birth of using not your hands to eat, but stuff like this to eat. This is all about civilization. It's all about being civilized, because kings and queens of old, you would eat with their hands. Like you have a feast.
Yeah. You'd have a trencher.
And then at some point, the kings and queens went, you know what? Those commoners can eat with their hands, but I choose to eat with a spoon and a fork. And somehow I don't get my hands messy, I don't get my clothes messy, and that's what it is to be civilized. And then, of course, everyone else wants to do that too, but they can't afford the right materials, so they end up tasting a lot of kind of weird metal wooden tastes until a material scientist come along and says, do you know what, I can give you a material that's even more inert than silver, as inert as gold, but it's going to be so cheap that you can all have as much as you want of it, that you won't even have to monitor your guests as they leave the table to see if they secreted it about their person. Because you ever go to dinner with people who've got silver cutlery, you can see that they're kind of just making sure where the silver cutlery is as you leave. Right?
Oh yeah, it's valuable.
We still got that
yeah,
it's very valuable. People lock it up,
Yeah.
Who locks up
stainless
steel
No,
cutlery?
you can have my
No
spoons.
one locks up.
Yeah.
Yeah, you can. It's almost. This is sort of an ideal world, right, where everybody gets to eat with inert cutlery and no one gets in it. If you don't have one, have my spoon. Yeah, it's everybody's. I don't care. It's like biros, right? They're everybody's. And this is amazing. This really is amazing. And people take it for granted that they can't taste their cutlery anymore. But this is new. This is not long old. This is, less than 100 years old, right? Is this ability to do this? So we should really, savor that.
Honor the spoon.
Yeah, and we, as you were pointing out, we did these studies and we catalogued the full tastiness of different materials. But we also then thought one stage further, which is, okay, so it's great, stainless steel's there and it's cheap and it's a really miracle material. What if you could design, take a material that does taste like tin and design a dish which takes into account the sort of slightly weirdy acidic taste of it and enhances it, right? So what if you had to order, I'll have the curried prawns with
a tin spoon?
The tin spoon.
Well, in fact, when you make zabaglione in the classic Italian way, you have to make it in a copper bowl, and I always assume there's some chemical reaction going on between the egg whites and the copper.
Yeah, actually, copper. So when you're whisking egg whites, you've got to get the foam stable, otherwise it collapses.
Right.
And what tends to make it collapse is the weakness of the kind of protein agglomerations. And if you can prevent that happening, then you'll strengthen the foam. And then copper does that. Copper actually goes into that foam and interferes with that, which is why that's one of the good reasons for whisking egg whites in a copper.
It makes better egg whites, but it must add flavor. It must add a copper.
It makes it taste horrible. But nevertheless,
but they're good.
You get your lovely.
But that's the thing
thing.
that's so interesting about this study is that in fact some of these tastes are perceived at least as pleasant. They're actually good flavors. It's not always a negative.
I mean, it's all subjective at the end of the day.
I mean, yeah,
and
it's what you're used to, what you expect, and so forth.
Our culinary culture has evolved.
Yeah.
And I suppose that's in the end, it's about your sophistication in being able to manipulate those sensory moments. But there's another angle to this which we haven't actually managed to kind of progress, but it is an interesting angle on this, which is that when we were talking about this work at conferences, there were a few medics in the audience, and the medics were like, do you realize that taste malfunction? So when people, we talked about unpleasant taste in the mouth as a result of different metals, but actually people have metallic taste that they develop in their mouth because of disease.
Right.
And it's a great predictor actually of certain diseases. So if you go and have a taste malfunction, it can actually be a predictor that you're going to get ill. And so wouldn't it be useful if you could somehow have a sort of standard taste test, which would very finely calibrate whether your taste is getting, better or worse, and so therefore you could intervene. And it doesn't exist. And we were trying to think, well, how could you do this? And one of the ideas we came up with is, imagine every morning you have cereal and you have your spoon, but it's designed exactly for your mouth. So the alloy exactly for your mouth, and it has a particular taste.
And if it should ever taste different,
exactly,
you're dead.
If one morning it tastes different, you're getting ill.
Go to the hospital.
You go to the doctor, and it might save your life. That might save your life. A simple spoon can save your life. I mean, we talked about washing machines earlier, but spoons really need, right?
Now you know why the London Times called this man, Mark Miodownik, a British brain box with a highly evolved sense of justice and not a bad sense of humor. I love it.
Well,
incidentally, I think it was Robertson Davies, the Canadian novelist, who had a doctor who would diagnose illness by sniffing his patients. And it turns out that's actually a good way of doing it.
Yeah, well, that's the same thing. I mean, actually, the sensory exploration of the world has essentially been taken a back seat in medicine.
We don't want to smell anything anymore.
No, we don't. I mean, it must have been a smelly time in those days, and let's face it. Yeah. But I'm sure that people's faculties were more sensitive.
Sure. They got used to it too. I mean, you can inure yourself to anything. Boy, I wish we had another hour. We're actually out of time. I could talk forever to you, Mark, but everybody should run out and buy the book, Stuff Matters. Just came out in the U.S., exploring the marvelous materials that shape our man-made world. And you can get it from Amazon from 1 to 4 weeks from now.
Yeah, it's discounted though. Look, 25%. That's
it's only $20. You get by the way, you can get the UK version for £6.89. So
yeah,
get it in the. I think that's still less.
I mean, it's I never really understand why
I don't get it.
Yeah, but
that's something materials science cannot solve.
Right.
Yeah, economics is something very, 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 very obscure. Mark is the professor of materials and society at the University College of London, and I think you're wonderful. I'm so glad you wrote the book. I wish we saw more of your radio and TV here in the States. I hope you will do more here.
Oh, well, yeah, I'd love to.
Yeah, just great.
Thank you very much. Well, it's very nice being on the show.
Thank you for joining me, and I hope Laszlo got to bed okay.
Yeah, there's less background noise now, so I think probably that means he stopped screaming.
Mark, thank you so much for spending your evening with us. We really appreciate it. Mark Miodownik.
Thanks. Pleasure to be here.
Really great. MarkMiodovnik.net if you want to see his website with lots of places you can read his writing in The Guardian and The Observer, and of course his scientific papers and his book Stuff Matters, exploring the marvelous materials that shape our man-made world. What fun. Science is just the best. We do Triangulation every Monday, 11 a.m. Pacific time. That's 2 p.m. Eastern time, 1800 UTC, late at night in Britain. But you can join us live if you're up. Big Ginge is up. And we'd love it if you watch live because we get great suggestions from you in the chat room. I steal all my best lines from the chat room. But if you cannot, we have on-demand audio and video of all our shows, 154 strong, at twit.tv/TRI, or you can get it wherever you get netcasts, iTunes, the Xbox Store, the podcast apps, and of course our great Twit apps, and we thank our developers, all independent developers who work hard. So give them that 99 cents on the iPhone, on Android, on the Windows Phone, on every platform, on Roku. Thank you for doing those. We really appreciate it. And thank you for being here. We'll see you next time on Triangulation. Bye-bye.